Hello and welcome to the English sound design live stream, which we're doing today here at HOFA Studios. My name's Chris and I'm ready to show you some tricks today and some basically fundamentals, some easy stuff to get you started with designing your own sounds. So what exactly are we going to do today? We're going to take a look at synthesis. So how do I make a sound from basically nothing? We're going to look at effects which are useful for sound design, so not your compressor, gate, etc., but stuff like multiband distortion or tool racks that include several effects and allow you to layer them or use them in a rhythmical manner. We're going to take a look at a little radio play that I made for HOFA. So you get like a little idea about the material sound design side of things. So things that are not exactly musical, but more linked to material things. And I'm gonna have a look at 2 new plugins, which I got new, and I opened them for like 5 minutes to look if they work, and they work. So we're gonna have a look at those. And if I'm still not running out of voice, after that we're gonna make some actual music with sound design. If you have any questions at any point, feel free to type them in the chat. I hope the chat works. There's no one writing anything, so I hope it's just no one writing anything at this point and not the chat not working, but we'll see about that. All right. We're gonna... Oh, there's someone. Hello, Sneaky Beats. We're gonna start off with Subtractive Synthesis, which is, well, in my opinion, the most easy kind of synthesis. And also one of the types of synthesis that has been with us for the longest time. And in order to do that, I'm gonna show you a little something in software for the beginning. And then we're gonna switch over to hardware because I got some hardware over here and it would be a shame not to use it. Yes, so if we look at subtractive synthesis, we usually have our oscillators that we start with. And from that point, we're always trying to subtract something from the sound. As the name suggests, we are using filters, or in this case one filter, to subtract some things from the sound that we don't want. So basically 3 essential parts. Our oscillators are used to create an initial sound. Those are then blended in a mixer, which is the second part, and the third part is the filter which removes things from the sound. Exactly. Starting with our oscillators, we're using Monarch from Native Instruments for this example. Monarch is like a, not copy, but it screams Minimoog at your face when you open it up, which is one of the, well, most popular analog synthesizers in the real realm. Not that software isn't real, but it's software after all. And yeah, we start with the oscillator. And what the oscillator does, it allows us to choose from different waveforms. So if we start off, we got this switch, which allows us to switch the waveform. And what I want to do is I want to show you how those waveforms translate to the frequencies we have and also to an oscilloscope. So I can explain why they are called what they are called. We're already starting with a little cheat because our Monarch actually doesn't have a sine oscillator. Why a sine oscillator? The sine is the most pure form or waveform because it only consists of the fundamental. In sound design, you have the fundamental, which is, well, should be the note that you play on your keyboard and feed into your synthesizer. And then you have harmonics, and those harmonics say more about the timbre of the sound and how it sounds than about the musical use. So what I did, what my little cheat is that I actually already used the filter to reduce the harmonics and to filter out a sine wave. If we look at this, I'm pressing an A on my keyboard, or on my on-screen keyboard in this case, because this keyboard is there and I'm here. And this oscillates at 55 Hertz. And if I turn the filter up, we're getting harmonics. And you can also see in the oscilloscope, we have this sine waveform, which defines a sine oscillator. And it starts getting edges and turns into a triangle. If we now look at the frequencies, what overtones or harmonics we got the third harmonic at, yeah, well, it's should be 165, but there's some rounding up and down, of course, in the analyzer. So this is our third, this is our fifth, and this is our seventh harmonic, which equals a triangle wave. If we now turn it to a square wave, you can actually already see the oscilloscope turning. We have the same harmonics, third, fifth, and seventh, and they are a lot louder in relation to the fundamental, which, well, just gives us a richer texture to work with. We can also change the pulse width of our square waveform or pulse waveform, however you prefer to call it. You see, it's not a perfect square in the oscilloscope, but you get the idea. So let's compare it again to the triangle. The triangle is a lot more soft, which makes it ideal for pretty much every smooth lead synthesizer sound you'd like to do, while the square takes up a lot more space. Talking about taking up space, the waveform that takes up the most space is the sawtooth, which means that in one cycle of the waveform it goes from minimum to high and then it just jumps back, which looks like this. When we can see it pretty well switching around in the analyzer, that we now have every harmonic, so every multiple of our fundamental frequency. So 110 is double of 55, then we have our third multiple and the fourth. Sounds terrible on its own, but it's very useful because of the rich harmonic content it provides. All right, switching over to hardware land. I've got my keyboard here, and let me enable this in the RME. Yeah, this guy is sadly a little bit noisy today, so there's no overdrive for us today, but we'll do without it. Yes, I got some effects behind this synth, in between the synth and my sound card, just because listening to waveforms gets your ears a little bit dull after a while. So that's why I have some little reverb on. Oh yeah, let's mute the software as well, because otherwise we're gonna have two sounds. Yes, little reverb. And basically you can see this is pretty much the same as in Monarch. We have our two oscillators. Okay, it's 3 in Monarch, but we can do with 2. We have our mixer section here, which allows us to blend our different oscillators. We have a filter, which allows us to filter out components of the sound that we don't want. And in the end we have envelopes. I haven't talked about those, but I'll be talking about those in a minute. And the LFO, of course. Yes, that's our main ingredients. I actually have oscillator 1 turned on right now. And I can switch between the different waveforms. So here we have a sawtooth, here's our triangle, and here's our square. We also have this shape knob, so we can change the symmetry of the waveform, which is the pulse width when we're dealing with a pulse or square waveform. It can also part the triangle. And same thing with the sawtooth. Then we have the second oscillator, which actually has some more options. So let's solo that. We have a pitch knob to actually pitch the sound how we want it. Yeah, we can also switch our waveforms. We have a choice of sawtooth, triangle, and some noise. Very useful noise, we'll talk about that later. And we can switch the octave, which allows us, for example, to have it either in a sub-octave, for example, for a bass sound, or in a higher octave for some octava-like sounds. We also have different modes this oscillator can operate in. One of those is sync mode, which allows two oscillators to work together in a sense that one of them provides a sort of reset value, because it always tells the other oscillator when it has passed one cycle and then restarts the other oscillator at which point in the waveform it is, whichever. I hope that makes sense. It allows you to make some crazy sounds, like, because now my pitch knob is not actually changing the pitch of the second oscillator, but the timbre, it's changing how it sounds, providing harmonic content. While my first oscillator stays the same. Yeah, that's basically our oscillators. Now onto the next part. This is our filter. We have a low pass filter here, which means it lets the low part of our frequencies pass and the highs are cutted. That's why you sometimes also hear a low pass filter referred to as a high cut filter. So you can hear those harmonics disappear. Also pretty interesting, on the Korg Monologue we actually have a oscilloscope which is showing us this kind of waveform. Which has some sharp edges, which means we are dealing with harmonic content. But if we reduce the cutoff, which means the frequency where our filter starts closing, we can see it getting smoother actually and turning into a way lighter waveform. All right, we also have a resonance parameter, which means that there's some kind of amplification at the point where the cutoff is set. So let's set it somewhere where we can actually hear it. Then increase the cutoff. So it amplifies the frequency which the cutoff is set to. We can actually turn it to the point where the filter starts oscillating itself. Producing its own tone. We should... That's my oscillators turned off right now. That's just the filter playing right now. I seem to have some velocity sensitivity on it and some key tracking as well. We'll come back to that later. But yeah, that's essentially our filter. Let's turn down the resonance again. All right, next up we have our envelope. The envelope is a modulator, which means it doesn't actually pass through audio. It means we can instead use it to modulate a parameter. In this case, for this synth, we can actually switch between 3 targets. We have pitch of oscillator 1, pitch of oscillator 2, and the cutoff. And what it does, you can actually see it pretty well at this switch, is that it allows us to shape the sound or the progression of the sound in the time domain. So we have an attack which describes how slowly the modulation on this envelope rises, and the decay which says how slow it decays. So if we set this to cutoff like I did, and then increase the intensity, which means the strength of the modulation, we can hear the filter is slowly opening up and then closing again rather fast because the decay is set pretty low. But we can have it smooth as well. Different example, let's change it to pitch. Which of course is, because we have our sync mode enabled, not changing the pitch, but the way the oscillator sounds. Pretty interesting. If we set it back to normal, we can actually have it pitch up and down. Same with oscillator 1. Or we can leave it on the cutoff, producing this kind of sound. We also have an LFO on here. As you can see, it's labeled LFO. So what's the difference between an envelope and the LFO? The envelope actually works periodically. At the end of a cycle from the LFO, it's jumping back to the start and doing the same again, which allows us to use it for some rhythmic stuff. It's the same concept of modulating a parameter with it, but it does that in a reoccurring fashion actually. If we change this to pitch now, and maybe use a triangle waveform, you can hear it's doing it over and over and over again at a rate that we can set, which is now synced to something interesting, to the host tempo, I guess. Why is it called LFO? LFO stands for low frequency oscillator, which means an oscillator which is running at a low frequency. And that totally makes sense because you can also switch from different waveforms. You can use sawtooth, triangle, or square for this. And it has a range which it plays at, which is just not in the audible range, but beneath it. That's why it's called low frequency oscillator. One funny fact about this low frequency oscillator though, it can actually go into the audible range if we switch it too fast. We can actually turn it so high that it comes into the audible range. We cannot precisely set the pitch. We cannot say, okay, I want this LFO or this particular LFO set to A4, which is at 440 Hertz. No, that's MIDI A3, sorry. But we can turn it into the audible range. And if we actually modulate the pitch or frequency of our oscillators with that, we're doing frequency modulation. We're modulating the frequency with the frequency of another oscillator, which is the principle of FM synthesis, which we'll come to in a moment. But for now, we can be happy with this kind of sound we have. Yeah, just slap some effects on there. Yeah, this one's noisy, but so much fun. So that's subtractive synthesis for you. As always, any questions, please put them in the chat. They're gonna help me make this workshop much more interesting. Thank you. All right, next up we got wavetable synthesis. And we're gonna do that in Pigments, I guess. Oh yeah, let me switch off the noisy one. So let's set this up. Yes, this is our wavetable synth, or it's Pigments, which does, well, like a bunch of different styles of synthesis. We can actually switch between analog mode, which has 3 stackable oscillators, between wavetable, which I'm going to talk about now, and also some sample-based synthesis. Now, what does a wavetable do? Basically, this synthesizer is built the same way that my little analog synthesizer is built, but it swaps the oscillator for a much more mighty component, because this one works with wavetables. What are wavetables? Wavetables are like tables which contain waveforms, but plenty of them. We chose between different waveforms for our subtractive synthesis. We can now switch between different wavetables which contain a multitude of actual waveforms. So if we look at this position knob, it allows us to switch between different wavetables, or different waveforms within the wavetable, sorry. And we want the morph enabled because it actually allows us to morph seamlessly between those 2 waveforms. How does it sound like? It sounds like this. Now this opens up a whole new world of possibilities, because we can also automate this position knob or add a modulator to it. For example, if I want to add an LFO to it, let's say LFO1, there you go, drag knob to control, yeah, exactly. You can see it's now moved by the LFO. Maybe a little bit fast. Where's my rate? There's my rate. We can also choose the strength of the modulation and then set up our waveform. Which gives us a completely different way of our oscillator to sound. And that, of course, depends very much on the wavetable we choose, because they can have like very different looks and sounds. Oh, that one is nice. Yeah, that's kind of my jam. Really nasty. Yeah, and wavetable synthesis is mostly about figuring out which part of the wavetable am I actually going to use. So you can just deactivate the LFO, and then scroll through the wavetable and see which bits you like. And if you want to go there, then just use the position knob or automate it in a way that it reaches that area. We can also, of course, use an envelope for that. So if we want to use envelope 2, for example, this envelope actually is a little bit more complex than the one we had over here on the monologue, because the monologue only had attack and decay, depending on which envelope mode you choose. But let's continue with software. Maybe it's a little bit more handy when you can actually see how it's running through the envelope. So we had our attack, which means it slowly rises. Let me just patch this to the filter as well, so we can maybe understand it a little bit better. Yes, very nice. That's our attack phase. Then it decays. And what we have now is the sustain phase of the sound. Well, what does it do? What does it mean? Sustain is actually when you keep on playing the note that you're playing. So if I'm holding down the note, I can now tell the synthesizer at which value this envelope will stay while the key is still pressed. And from there on, I can actually also set a release, which means after I let go of the key, how fast is this value returning to 0. Let me just put some release on the VCA envelope as well. Yeah, VCA, that's a good one as well. We haven't really talked about VCAs yet. VCA stands for voltage controlled amplifier, which means there's an amplifier which is controlled by a voltage, and this voltage is set by the envelope in this case. And what the envelope actually does is that it tells the amplifier what kind of volume it is applying to the signal that is flowing through. Why is that important? Actually, analog style oscillators, they are running permanently. They are not just activating when you press them, they are running permanently, which means if you don't have a VCA, that they're continuing to run and they are making noise for forever, actually. And they don't care if you let go of that key or play that key. You can't put anything in there because they're just oscillating away. And that's why you have an VCA, which is kind of like a sidechained gate, if you want, or a sidechained expander. And that controls how much the sound sounds, actually. So if we increase the attack on the VCA envelope, we can hear it slowly creeping in. We can set the sustain a little bit lower, so we have a actual decay phase. And it has a release as well, which is now set to 20 seconds. So we also have it on the filter, so yeah. That's a very smooth release, which would, if you play many notes in succession, would create some terrible clusters, but that's okay for now. All right, let's set this back. Yeah, that's basically Pigments. What else do we have in comparison to our subtractive synths? We also have effects in this particular plugin, but most recent Wavetable synths have a effect section, so you don't need your noisy pedals, but you can apply those effects right here. So some delay, some reverb, whatever you want to choose. Yes, that's Pigments, a synth I use quite a lot at the moment because of the several different ways it has to produce sound, analog, wavetable, samples. So that's pretty nice, but you can of course also use Serum, which some people like to use, which has the, well, actually a very similar feature set. You can choose your wavetables. And switch through those. You can also already tell some of those wavetables are actually created by sampling. So someone imported a sample into them, and you're just going to scroll through that sample. So if we put an envelope on it, that looks a bit like this. Oh no, other way around, wait. We can actually, it says bottle blow, so I can imagine someone actually blowing over a bottle to create the sound. But we can of course stop at any position in this sound now and play that. There's a question in the chat, I love those. Does each oscillator affect only a particular part of the sound, like when using the 3x oscillator? What do you mean by 3x oscillator? Are you referring to the FL plugin? Actually, you can use your oscillators to do very different things. For example, if I go back into Pigments, sorry for switching around a lot. I can use different strategies to use those oscillators. Oh my god, init preset. Please, software developers, if I don't want any interesting sound to open up when I open my software. I just want a blank canvas, please. That would be so handy. Okay, let's switch to analog. So we have our 3 oscillators. And as I said, there's different strategies. We can use them to pitch them in different ways. So if we, for example, want to stack some sawtooth waves, this is set to 0 semitones pitch. This is set to 12 semitones pitch. And then we can just blend them in to make it thicker. We can also layer a sine below for a sub bass. So there's one strategy you can use just stacking them, but you could also do completely different things with them. For example, that's for one thing I do in the sound design course is that I make drums out of one instant of Pigments, which consist of one clap, one hi-hat, and a, what do you call it? A kick drum, of course. Kick drum, essential. And I only use, well, the two engines of Pigments for that. And how do I do that? I can actually control the volume of each oscillator by, well, using the mixer and the pitch, which means if I, for example, use a function. Functions are kind of like multi-point envelopes or sequencers in Pigments. I can create a function that looks like this, and it sounds like this. Not very interesting so far, but hang on for a second. And there we go, and I have like an 808 style kick drum. And now this is set to 1/2, so at 120 BPM the other quarter note goes here. Oh no, this is set to 170. Oh god, joint bass, sorry. Let's go back to 120. So now we have our, kick drum here, and we can use another function to, for example, make some hats out of another oscillator. So we go to functions, function 2, and say we want 8 notes. And we apply that function to another oscillator. And then we say we of course want a snare or clap on 2 and 4. Oh no, that's the wrong function. Yeah, and that's another way to employ 3 oscillators, to just use them for different purposes, different rhythmical aspects you want to do in your sound. So they don't have to be like continuously playing at the same time. So now one oscillator is doing the kick drum, the second one is doing the hi-hat, and the third one is doing our snare. Oh, there's a comment. The snare drum sucks. Kitchen was almost there and then you ruined it. Keep practicing and showing those people how to use their stuff. Yeah, let me just do that. But that's the idea. Of course, it sounds pretty simple. It would get a lot better if we use phase modulation and frequency modulation to change those sounds. But actually, you can use 3 oscillators to do entirely different stuff with them. Thank you for coming to my TED Talk. Yes, back to wavetables. Yes, quick comparison of, well, it's not an in-depth comparison, but essentially Serum has the same components, a filter, What's a bit different, I guess, is that we have a separate noise section. So we can add some noise to our signal, which is pretty useful because noise fills up the frequency spectrum rather fast, which is a technique often used in, for example, dance music, where you have like super saw leads, which already consist of different sawtooth waves stacked onto each other. And because that is not enough, you can just add some noise to them to make them even fuller. Yes. I hit caps lock, sorry. We also have a sub-oscillator, which just means it's a very simple oscillator with not as many features. We only have some basic waveforms, but we can use it to add some sub to our sound, for example. That's not why it's called sub-oscillator. It's called sub-oscillator because it's a simple version of an oscillator, but most people use it to add some sub to their bass sounds. Yes, we have a filter. We can choose what goes through the filter. So I can actually, right now the noise is excluded from the filter. Now it's going through the filter. That's pretty interesting. Some synthesizers let you choose between different ways of routing the audio through a synth. Of course, we also have modulations in the same style as Pigments here. So we can add an LFO to this. And an envelope to that. Of course, we have our effects over here. Yes, distortion, that's exactly what I wanted. More distortion. Thank you. And you can also watch what your modulations are doing in the matrix view. Yes, so everything is the same. But now let me switch over to Massive X, which is like the, well, it's not the upgraded version of Massive. It's basically a completely new synth, which boots up with a init preset, which sounds like garbage, just how I like it. Thank you, Native Instruments, that's actually very kind. And exactly what I wanted to show you in Massive, we don't have actual options like, do I want my filter to apply to those components and those components? No, I can actually route my entire signal flow however I want it. So here the F stands for, does it stand for filter? Yeah, I hope it stands for filter, but it says Asimov, which is the filter that we have here. Oh, let's do something with harmonics. Now I can say, okay, delete that wire, and oscillator 1 goes right into, that's my utility slot B, I guess. And the filter no longer does anything. So if you're doing very complex sounds, this gets very useful because, for example, with those drums I had, you could now say, okay, I need the filter only for my snare drum because the snare drum is the most intricate part of the sound, and now I just want the filter to apply only to the snare drum. That would be totally possible here. Otherwise, same thing, of course, different waveforms. Change your waveform here, create your modulations by drag and drop. That's the wrong LFO. Yes, very well. And envelopes work the same. Oh no, I bypassed the filter, that's not gonna do anything. Let's do pitch. Yes, great. And then I here have my well, it's not limited to effects because it can actually do a lot more, like for example frequency shifting. Wait, is it? Okay, let me turn this off. This got annoying pretty fast. Surprised. Did I put it through here? No, I did not, because the frequency shifter is in front of the filter. So let's reroute that oscillator into frequency shifter. Frequency, okay, let's put the filter back in. That's our frequency shifter, which, as the name implies, shifts our frequencies. But we'll get back to that when I tell you about effects. What's also important about the architecture of Massive X, we have our polyphonic area, and everything in this area is polyphonic because we have different voices. We can play 2 notes at a time. And you can imagine that like this area of the sound actually has all of these components in multiple instances. So we don't have only one oscillator, but we have one oscillator per voice. And then it goes into the effects, which are monophonic, meaning they are just processing the audio that comes out when you add up all the voices. So if I were to, for example, use more voices for a unison function, which means I can use 3 voices to play the same note, which makes it thicker because they are spread in the stereo field. That's just 3 voices on top of each other, and then you can spread them. Probably works best on headphones or studio speakers. And you can also spread them concerning the pitch of them, which allows you to give you a very thick sound without actually without actually wasting one of your oscillators for that. Which allows for some more complex sounds. Yes, that's Wavetable Synthesis. Next up we got FM. And for FM we're using FM8, which is also by Native Instruments. And exactly. I also talked about that when we were busy with the analog synth, because it had like a frequency modulation feature. But frequency modulation as a synthesis form is a little bit more complex, because it usually just employs oscillators that use a sine as a waveform and allows you to, well, create kind of complex modulations between those oscillators. So, for example, in FM8, as the name implies, we have 6 operators. FM8, 6 operators. Yeah, we also have a filter and a noise generator, which are adding to that, I guess. But we have 6 core operators. They're called operators because they can have 2 functions they operate in, of which one is a modulator. Modulator means this operator is mainly used to modulate another operator. And they can be a carrier, and a carrier is a oscillator that actually gets sent to the output and is, in this case, modulated by another one. So, in its simplest form, we have this piano sound, and we're gonna delete that and do it completely new. Yes, thank you. So, let's use one operator as a carrier, so it goes to the output. You can hear it's a sine wave. You can also change it to other waveforms, but that's cheating. Don't do that. You just use sine waves for FM. No, do whatever you like and whatever creates an interesting sound. But in the beginning, FM synthesis was just a very cheap way of synthesis, and that's why it was, well, limited to sine waves, because you only need a sine oscillator then. And you can make quite a palette of different sounds just by having two operators modulating each other. So if we now want to create a modulation from our second operator to our first operator, we can also see a partial view which shows us our harmonics. We can see those getting more. So with just two operators, which are actually running at the same frequency right now, we can achieve everything from a pure sine wave to this. And it gets even worse when we, or better, when we, yeah, you gotta be very delicate with this one. Because now we have actually built a feedback loop, because operator A is not only a carrier at this moment, but it also turns into a modulator, which modulates operator B, which modulates our main carrier, which modulates our, you can see I'm stuck in a circle here. This is a feedback loop in frequency modulation, which pretty fast ends up in just noise. Thank you. If you ever wanted to know how you can make noise out of two sine waves, there you go. Now, how does this get interesting? We can actually change the ratio of our operators. Which means our fundamental stays in the same place. But the modulation, the modulating operator is going through the harmonics. So if we listen to the modulator instead, just a sine wave. Let me get my oscilloscope back up. Yes, oscilloscope, awesome. Sine wave, sine wave, sine wave, sine wave, also a sine wave. It stays a sine wave. But if we instead listen to the operator which is modulated by this, our carrier, we can make some very complex waveforms just from this. And that's just two of them. So if we want to do our piano again, we can just change the envelope of our second operator. Yeah, I'm a little bit limited on this little keyboard. If we want to make this sound a little bit more complex, we can, of course, kind of use this as our, well, let's say bass waveform. So we're doing a two component FM synthesis. We say this is our basic sound because we don't want all of our harmonics to decay. And then we use two separate operators for the attack phase of the sound. So we turn these back up to 17, 18-ish, and also output this. Sounds horrible, great. Little less modulation, a little more action, please. Something like that. What is it useful for today? Of course, all those classic FM sounds, like for example, the lately bass is made with FM synthesis. You can have some of those pianos. You can use it for bells, but also for completely different sounds. You could make a pad that just changes with the frequency modulation. So, for example, if I just return to my two operators, I could just change the characteristics by giving this an attack. Give it a little bit of a release. This one as well. Yeah, those envelopes are a little bit gruesome by today's standards, of course. And then we can just slap some effects on there. Like some phaser. Where's my chorus? And maybe some reverb. Is there reverb? Yeah. That's my phaser. And we created a spacey pad. Oh, with a bell on top. Yeah, you cannot do a sound in FM synthesis without a bell being played somewhere. That's FM synthesis for you. All right. Next up, we have additive synthesis. Additive. Yes, thank you very much. I actually don't have a additive synthesizer at this moment, but I can show you using an FM synthesizer. What does additive synthesis even mean? Well, we had subtractive synthesis, where we started with a rich waveform, and then we, well, reduced some of that waveform using a filter. Additive synthesis actually works the other way around. It just lets you add up to your sound by, well, just again using different oscillators. They're called oscillators in additive language. They're called partials. So partials are also, again, a term that is also used as a synonym for harmonics. And that's actually what they do. They are harmonics, and usually a lot of them. A complex additive synthesizer gives you control of, well, I guess the standard would be 512 partials or 256. It's always, yeah, it's a crazy amount. And then you get to have individual envelopes on every one of those, yeah, partials. Let's not call them oscillators anymore. Now, by now, which is the synth which had the highest amount of oscillators? Right, FM8 had 8 different operators, or let's from now on call them partials. And we can just play additive synthesis by sending all our operators to the output and then tuning them up to resemble a harmonic. We can now change the volume of every one. So in the beginning it's just a sine wave again. Second harmonic. Third. Fourth. Fifth. And sixth. And what additive synthesis now does is that it allows you to control each one of those partials, for example, in the envelope. So we can give them all different attacks. And again, I'm not using this FM synthesizer for frequency modulation, because frequency modulation is what happens when you send one of those operators into another operator, but I'm just routing all of them parallel to the output. Now we could of course also make the fundamental decay over time. Now that's our additive double bass, as you can hear. Sounds totally like a double bass. Is it practical today to do additive synthesis? Yes, it is, but maybe not in the classic form of additive synthesis. There are some additive synthesizers that actually allow you to use something called resynthesis to mimic another sound, which makes it pretty appealing. And what it does, it analyzes a sound and tries to rebuild that by using the partials. Just some basic science behind that. It's the same that Fourier did with the Fourier transformation. Every sound can be divided into an addition of different sine waves. And so you could use an additive synthesizer to mimic any sound you want. But you should bring some time if you really want to make your own sound on an additive synthesizer. One way, well, not maybe around that, but yeah, one way we can relive additive synthesis today is by using synthesizers like Razor by Native Instruments, which is under the hood a additive synthesizer with, I think, 256 partials, but it is built like an analog synthesizer. So if we go, give me the init preset, please. Yeah, it's even hidden in a subcategory. But I can find you, initial preset. Thank you. So where's my keyboard? Keyboard back up. Yes, so this is a oscillator which allows us to morph between pulse and saw. Very spectacular. And then we can use a filter to, oh my, that's a lot of resonance. Yeah, thank you. To actually remove some harmonic content again. So let's set this to output. And it looks like it's a oscillator going into a filter, but underneath it's an additive engine which just models what a filter would do to the sound, giving this synth like a very different characteristic compared to other synths. We can also do some interesting shifting, for example, by using those, what are they called, dissonance effects, yes. Dissonance effects. Which one was the one I liked such a lot? Let's use the stretcher. Stretcher. Yes, this allows us, for example, to stretch the frequency spectrum or stretch the fundamental frequency of the partials, or even push them together. Oh, very interesting sound. So that's how you get additive sounds. Of course, they are not as complex or intricate as a additive synthesizer with 256 oscillators and 256 matching envelopes that you can configure. But it sounds pretty interesting to me, at least. All right, next up we got sampling, and I want to show you sampling with a little patch that I made myself. This is Native Instruments Contact. It's kind of the industry standard for sampling. At least it still is. There are competitors trying to change that. For example, Hellion by Steinberg. But at the moment, if you look what big sample libraries are produced for, example, my Spitfire strings, for example, are made for Contact. So there's a lot of third-party instrument libraries available for this platform. And what I did, sampling works with a recording of specific notes of an instrument. I recorded my melodica at home. And what I did is I played some notes. Oh, my play cursor is a little bit glitched. There it is again. Now, if you're very good at hearing intervals, you might have already seen or heard that it's a minor third. And I told my sampler exactly that. I dragged my samples into here and said the sampler, okay, this note is a C, this note is a E flat, this is, and so on. And that allows me to just sample, well, those 4 notes per octave, but I can play the entire octave because it's pitch shifting between those. So. And that's basic sampling for you. That's the mapping editor. If you load a instrument that you bought into Contact, you're mostly going to see a beautiful user interface that someone created. I'm very bad at graphics and Photoshop and stuff like that, so I'm just tweaking the parameters without a user interface. I'm just going under the hood and, for example, drag those samples in here. This is my mapping editor, which has my different notes that I could play on the x-axis, and then on the y-axis I got velocity. If I want to do, for example, a velocity-sensitive instrument, which of course allows you to do a much more natural sounding sample of, for example, a piano, which sounds different at every velocity that you play. Yeah, that's about it about sampling at this point. We of course also have our filters, for example. I put some filters in here which are controlled by the velocity. You can hear it's a low pass and a high pass, so both the low frequencies and the high frequencies are reduced a little bit when you play softer, just to give you the impression that the instrument behaves a little different when you play softer, which actually adds a lot to playing this instrument because it feels different. Yes, spectral sampling, also very interesting one. I had this sample of a piano flying around and now my synth can't find it. Now that's just perfect because I actually already have that here. And drag and drop it in and maybe clear my selection. Thank you. So, am I in the right? Oh, there's a... Yeah, that's what happens when your old preset is loaded. Yes. Root node, set that to 2. Yes, the root node is like a reference point for a sampler which tells it, okay, the sample I just inserted is a piano playing at D2, so the sampler knows at which pitch it has to expect that sample to be in order to make it playable on your keyboard. So this is, as you can hear, a chord which we recorded 20 meters from here, over there in the big studio, using two Neumann M149s. Beautiful sample. And now we're gonna completely destroy it. We can, of course, pitch it up and down to make some like ravey sounds. But what we're gonna do now is we're gonna make use of this spectral editor that we have in Iris 2. So if you go back, this is our initial pitch of the sample. We can use, for example, this lasso tool to just select some frequencies and say, oh, I just want to play those. Now you're going to say, Chris, I could totally do the same with just a bandpass filter or a combination of a low-pass filter and a high-pass filter. And maybe you're right, but this is a lot easier because it's very intuitive. You can see your frequencies and just use the tools to paint something in. Octopus. I made an octopus. Nice. If you ever imagined how an octopus layered on top of a piano sample would sound like, it's like this. It's very nice because I used the paintbrush selection tool. We can now see those two lines crossing, and then there's this big thing in the middle, and you can see it pretty well on the frequency view, how they're getting closer to each other. Of course, the lower frequencies are louder because that's just the nature of this sample that I recorded, because it's a piano chord decaying, and naturally the harmonics disappear before the fundamental and lower frequencies. Now add a complete synthesizer on top. Distortion. We can also use a filter. Oh. Oh. Okay, I'm gonna save this patch right now. Octopus patch. Bass. Yeah, that's a bass. Oh. And what a bass it is. Okay, that's spectral sampling for you. We're gonna move on because there's not much time today. We are already 17 minutes in. Oh my god. Okay, you also forgot your sample. That's fine. I can just drag and drop it into the plugin. Yes, this is Pigments again, and I like to, as I said, use it because it also enables me to do granular sampling. If I switch it off, it's just, oh, that's pretty low. Maybe boost that up a little. Where's my root node and stuff? Sometimes you forget how you use all those different plugins. There we go. And I can change the start point of the sample, which for example allows me to put it in reverse if I apply an envelope to the start and put it in reverse. Oh, that's just the start, not the position. Okay, sorry, my bad. But that's exactly what's gonna happen if we switch on Granular, because what Granular does, it slices up your sample into little grains. That's why it's called Granular, which are like little audio fragments of, what do we have here now? 129 milliseconds in this case. And then those are, well, not randomly spawned, but you can change some parameters to do that. You can change the size of those grains, which means if we turn that up, the sound gets a lot smoother. If we turn it down, it gets a lot more rhythmical. We can also change the shape, but this trapezoid form is the most used. And then we can set a density, like how many grains we want to spawn at a second. And if we change the start now, we can go through our sample and say, okay, I want my start position for the different grains. Yes, it is randomized a little because I put this up. We can also have the same played every time, which allows us, for example, to have a softer part where we only play the last bit of the sample, or we can have a very attacky and rich part when we go to the start. Now, you usually want a little bit of variation, so this allows me to randomize the start point of my grains, which can range over the entire sample, which can be interesting. Or you can focus it to a little area, which gives you some control over your dynamics if you have a decay sample like this. You can also randomize the pitch of each grain to make it completely atonal. If you ever wondered how it sounds if you put 300 piano players into one room and they start arguing with each other. Awesome. Then you tell them to shut up. They go very quiet. But over time they're gonna come back there, so they're so gonna come back. Yeah, and as always we can modulate all of those parameters. Also use an LFO if you want to. Very useful for making very experimental sounding sounds, because, well, you're not going to use this as a lead synthesizer, which does not mean that I say you can't make a lead synthesizer with granular synthesis. Yes, of course you can. It also depends heavily on what sample you put in there and what kind of parameters you use, of course. And it's always a challenge to use a form of synthesis or sampling which is not the most suitable for creating a sound. That's an interesting approach to sound design as well. But this is just made for great pad sounds and evolving textures and stuff like that. That's what I would use granular synthesis for. All right, 2 more synthesizers to go. Yes. We are getting to the physical modeling realm, which means there are no longer samples involved, but we have a modeling of an actual instrument. In this case, we have the Swarm Engine cello, if I remember correct. Yeah, exactly. And this doesn't do anything if I don't map my parameters right. So let me just do that while I continue explaining what it does. It seems like I can't. Probably my MIDI controller. No, it is there. Okay, let's reload the instrument. So what they did for this instrument, they looked how a cello actually behaves in nature and tried to model that using synthesis or a computer model. And they made a computer model of a cello, and that sounds like this. If I can turn, yeah, there we go. That's my expression, which is important because without expression, this music would mean nothing. No, it just wouldn't sound. So no samples were harmed in the making of this. Maybe they were harmed in the making of this instrument, but this is a very lightweight plugin with, I don't know, 30 megabytes or something like that. It can't contain all those samples that you would expect when you hear this kind of sound. String SSC. As you can see, this instrument knows when to switch between staccato and legato. It also has those slur articulations. It just puts in there when I play a low velocity. So this comes from analysis of how cello players play a cello, and then they did the same. They built an engine that analyzes what the player puts in there. We can also change some parameters. For example, if we lower the bow pressure, we get like a flotando, a bit more of a flute-like sound with more overtones. We change that to scratch, then it's just the bow scratching. Yeah, that's just amazing. And we can change, for example, the bow position, how that alters our playing. That's just too low, sorry. That's what happened last time. There are some key switches in here that actually change something. And if you trigger them, you might lose your sound because it's expecting you to play in a particular way, but I just wanted to do, well, just like it does, interpret everything I play. You can also see they also modeled it in the optic of the plugin. And that just changes the tone. Yes. So that's one type of physical modeling plugin for you. Another one is Chromophone by Applied Acoustic Systems. This is more like a toolbox that actually lets you change quite a lot of things. Usually to show that, I'm using one of those marimba sounds. Then we have the play view here, which is like a simplified view of every parameter we actually have. Just a marimba for you. And it's modeled in that way that we have three main components. We have the mallet, which is used as an exciter to excite two resonators, of which one is those marimba plates that you actually have on top of the marimba, and then those tubes or resonators beneath those plates. And if we want to go crazy now, we can actually change the plates of the marimba to drum heads. What does that remind you of? For me, it sounds like a timpani. Well, remotely at least. Or if we switch back to the marimba. We can change the exciter and turn off the mallet and use noise as an exciter. Now that's a little bit filtered. Is it better there? Yeah. And now we have the sound we would get when, for example, bowing a marimba. You can of course use sample instruments that do the same, but physical modeling gives you a lot more control over the sound. And we can of course also combine those. So we have a marimba which is at the same time played with a mallet and stringed with a bow. That's physical modeling for you. All right, I really need a break right now. So we'll be gone for like 10 minutes so I can get some water and do something for my voice. And then I'll be right back and we'll see what we'll do after the break. See you. Hello everyone, and we're back at the sound design workshop here at HOFA. I hope everyone grabbed a cup of tea or something. It's starting to get cold outside. Please look after yourself. I also need to do so because my voice is already cracking because I'm not a professional singer. Sorry. All right. Looking at the clock, I decided to jump over the effects because, well, everyone probably knows effects. And if you have any questions about effects, just put them in the chat and I'll try to explain what a ring modulator does. I'm probably going to do that anyway in this project. What I instead wanted to do is show you a little radio play project that we did for HOFA. And just show you the project and how I made some sounds from scratch for this project. It all started with a script that I got. Someone wrote this radio play and gave me the script, and I had to decide what are we gonna do with that, and I did that. Yes, let's just have a listen. The language of the radio play is sadly in German, but I'll just tell you what it's about. It's about a hitman who's called Vortex. He's not really a man, he's a monster. If you think about, for example, Rex from Mass Effect, that kind of guy. That's that kind of guy, yeah. Not saying he's a Krogan, but he might look like one. And then we have Jameson, who's a robot. And Jameson is pretty unlucky because he's tied to a chair in this scene. It takes place in a deserted factory somewhere. And basically what happens in the script is that they, well, insult each other a little bit. That's what happens in this part. Let's switch this back to seconds. Yes, they insult each other, or at first, of course, Vortex enters the scene. Then he gets a phone call. Some alien talks to him, and in the end, he tries to continue their little fight they have with words, but gets interrupted by an explosion. Spoiler! Sorry. Let's have a listen.
Ihr kolonische Klonmaschinen. Immer wollt ihr die Unterdrückten sein, die Kämpfer, die Rebellen. Oder gibt man euch einmal die Chance, die Zukunft eurer Spezies in die Hand zu nehmen, holt euch aus der Simulation und ihr wollt nur noch zurück in eure heile kleine Welt. Ich verachte euch zu sehr.
Interessante Verhinderungsstrategie, muss ich schon sagen. Einfach dem Gegenüber den an den Kopf werfen und hoffen, dass es so aggressiv wird, dass es irgendwelche Informationen herausholt. Sehr originell, das habe ich zu den Filmen funktioniert.
Ja, bitte. Aber
ich meine nicht 21.
Und da fängt unser kleines Missverständnis schon an. Das hier wollen wir eine verlieren. Das machen sie nicht.
If I think about it, there shouldn't be reverb at the end, but let's say this is a rough edit, and I'll just show you what I did here. We're starting off with the ambiences. We have two different ambiences or atmospheres, one of which is this one. Yeah, I made this in Pigments, mostly because Pigments has a selection of nice randomizing modulators, which I used to just make some digital noises, because I imagine that's what the world's like outside. And we can hear the door is closed at the start, and we just no, it's open exactly, but not fully open, and we can hear the first character vortex stepping around outside, and then at some point this ambience gets replaced by the inside ambience, which is a recording. Let me just show you the recording. This is a recording. I can show you, where is it? This one. That I made with a Zoom pocket recorder, the H6, and I put a little condenser mic, not on it, but on a separate stand to be able to, well, not have to hold it in my hand. And I set that up, and I recorded a little aperture that I use to check on my blood pressure. You actually can you can hear the agonizing sound of it crunching my arm. Incredible. And then I pitched it up by an octave using a pitch shifter. Yep. Then I used Shaperbox to add some modulation to it. And Decapitator for distortion. Oh, oh, it's not playing at that moment. So I'm terribly sorry. Let me solo just the right thing. Yeah, there we go. That's the one we were talking about. Without effects. Of course, some reverb on it. Pitched up. Modulation added to it. And then it's just crunched using Decapitator. Yes. Second atmosphere. Yeah, that's actually our fridge at home. So if you want to learn some German, Kühlschrank means fridge. Ah, takes me right back. And I actually left it in there. Just like that, because no one knows how my fridge at home sounds, so except for people who visit me. Yes. Then next up we got footsteps. And I made those in Weaponizer, which is a tool by Krotos Audio. They are I really need some tea in between. They specialize in plugins for post-production. Oh, and if you're a HOFA student, you get 50% off when ordering from them. When you're really a student. They're gonna ask us back if you really are a student. And what it actually does, it's called Weaponizer, and it's made to actually imitate the sound of guns. And it comes with a gigantic, is it gigantic? I don't know. It comes with several firearms that are in there. So you can go, okay, I want a shotgun sample, and pick a shotgun sample. You can say I want an assault rifle that is also a shotgun, and then find out that that doesn't exist. And then there's all your guns. I don't have many post jobs where I actually deal with firearms, so I used it to create my footsteps. Why did I do that? Because the underlying engine is very interesting and allows you to create a variety of sounds by just putting in some samples. For instance, we have those four categories. We have our onset, white on yellow. That's really, wow, Jesus. When it's highlighted, it's barely readable. Where I put in some samples of my keys. So just I had my car keys in my hands. I use different samples for variation. Then next up we have some samples of footsteps. That's just me stepping around in the kitchen. Yes, and I threw those in there. The key samples are in the onset tab and the footsteps are in the body tab. So if we go a little bit back where we have steps, so those steps are just MIDI notes to trigger it. And we have those different layers. So here's the keys munching around. Here's the actual footsteps. And because our hitman or hit monster is, I don't know, 300 kilos heavy or something, I added a thumb layer, which is just a synthesizer. Turn it off, you get nothing. Turn it on, you get a synthesizer. That is doing some sub for that. And now what it does with every footstep that I MIDI into it, it varies those samples because I set them up as round robins. That means it plays a different sample for every of the footstep, which already multiplies the different the amount of different footsteps I can get, but it also varies those parameters a little because I have those knobs here that I can just turn, and when I enable drunk mode, very nice way to call it, drunk mode, it starts varying, for example, the speed of at which my samples are played. And yeah, that's very useful. You can also say, okay, I want the keys to sound a little bit time-wise after the actual footstep. Oh, that's a lot better actually. Yeah, that's a little bit dramatic, but somewhere there. And now with every time I click on fire to trigger this plugin, or to if I play a note in MIDI, it will generate another sample. Of course, it gets a little bit random at high speeds because the key samples aren't really cut. So we'd have to go in there and edit those a little so we don't have so much overlap between the steps. Yeah, probably that layer is a little bit overkill anyways. But if we now also put some panorama modulation in there, it's just gonna get very realistic footsteps. And if you work, for example, in game audio, where you need those variations, it's very handy to just use a tool like this, so you can just create variations and don't have to worry about layering each single one of those footsteps. Same for a movie. Just mimic your author with a MIDI note. Is the trigger? Yeah, there it is. And just follow their steps with the keyboard, and there you go. Yes, we have those footsteps. Then we have the actual door opening. That's my door again, of course, at home. There's some extra noises in there. So that's where we go into the Foley realm, where you try to imitate character noises very, very closely, how someone would open a door. Then we have this ringtone, which I just made in Massive. And the pickup noise at the end. Got some EQ on there, a filter, another filter. Because we don't want a full range sound coming out of a phone speaker. That would just not be realistic. And it's actually made by an LFO varying the filter frequency very fast. Then macro 9 is changing the frequency and the actual dry wet of a frequency shifter. Yes, that's our ringtone. Then we have some simple button noise, which is "Hello, old massive. Thank you, old massive," which is just a very simple square. Of course, with a lot of reverb on it, but that's more like the mixing aspect of things. That's it, and an explosion. Underwater explosion. Yeah, I guess I just picked something from Soundly. If you wanted to be a little bit more, well, specialized, you could of course layer your own explosion. For the Germans, we're doing that in the sound design course, which you can actually book right now at hofa.com. For the German ones, the English ones have to wait a little, I presume. Yeah, that's our explosion. And then we have this riser, which imitates the blast wave that is coming from the explosion, which actually is far away, and it comes closer. Yeah, that's Pigments once again. And for this rising effect, there's two ways, well, two main ways you can create risers in synthesizers. One is using an envelope or an LFO, but then you get a riser of a fixed length. Or you can just use a macro and throw every parameter that you want to rise onto that macro and just automate that in your sequencer. And that's what I did, because it allows me to, for example, if I wanted a riser that stops in the middle, then I could easily do that. So it's just a very flexible way to create your risers. Yes, what do we have modulating here? Wavetable amount, some phase modulation, unisono spread. That's a good one to automate on a riser, because you have it like a simple one voice thingy in the beginning, and then it spreads out in the stereo field, and also detunes, adding some atonality. That's something you can do to create risers. And of course, filter, opening up. That's all the things that we have in the actual radio play, which leaves us with the voices. Let's pick a little bit which we're gonna take. Yeah, this is our hit monster Vortex, just saying, you, how do you say that? Poor little machines, or something like that. And it's made of 3 layers, which I'll show you. This is our main layer, which is, well, channel strip, which just prepares the voice before going into the actual, yeah, let's say voice changer plugin. So we're giving it a little bass boost and some compression. Let's see how that sounds.
Ihr kümmerlichen kleinen Maschinen.
Ihr kümmerlichen kleinen Maschinen. Yeah, something like that. Exactly. There's another EQ that does some EQ things. That's a typical EQ that does EQ things, I can tell you that. And then in the middle we have the plugin which actually changes the voice, and that is quite the complex plugin. Again, a tool by Krotos, which just combines a lot of plugins under the same user interface. And it's made specifically for changing voices, which is why it has some tools that are, well, just optimized for dealing with voices. You can think of it like, for example, we have our own HOFA system, which allows you to combine different effects under one surface. But this is, well, it's just made for voices, and it comes with a lot of presets for voices, and those work pretty fine. So going out, we're splitting our sound into 4 ways. One is going into this pitch shifter, which does 4 semitones lower. Then we have another pitch shifter. This one does 6. And the art of changing voices is to always, well, keep the understandability of the actual vocal up. I guess most of you are not German and do not understand what Vortex is saying, but picking and designing those sounds, you also always have to have in mind that some people want to understand what that character is saying afterwards without subtitles. I could have made subtitles. Yeah, I don't know. So here's another pitch shifter. That's very dark. And all those pitch shifters go into a flanger chorus, which is very subtle and not doing very much. Then into a ring modulator. Yes. At the same time, we have the input directly going into a noise generator, which creates noise. I guess they use something like a vocoder for this, so it matches the spectral input of the actual voice, and that goes straight into the output, while the ring modulator takes another detour through a granular option, which also adds some little bits on the side which add to this full sound. That's our main sound. Then we have a second one, which just adds a little bit, also with a pitch shifter. Very interesting thing about this particular pitch shifter by Soundtoys, you can change the pitch and the formants of the voice separately, which allows you to do something like this. So that's like a very large Smurf, which is still a Smurf, but has a little low voice. Oh, let's try the other way around. Very weird. Or just leave the pitch. Change the formant. Very interesting to make sounds with that. And then it's feeding into a ring modulator. You see, ring modulators are really key to sound designing. Ring modulator, that's where it counts. Oh yeah, and then this layer, very interesting again. Another Krotos tool. Reformer Pro, which lets you perform sound effects live. And in this case, it's a library of a black leopard or cheetah, depending on where you are. And it's made playable by audio, which means I can just feed the same audio that I use to create my voices to generate this bit, and yeah, that creates this kind of sound. I can also did I turn this up? Did I pick the right input? Is this doing something it should? Sorry, give me a... Oh, it wasn't monitoring here. I could also use my synthesizer to play this plugin. right now I'm turning the cutoff noise, and it's reacting to that. Take a listen. Rather soft, and then full on beast. So very useful tool in post-production as well. Very nice to do that. And that all adds up to Vortex.
Und dann gibt man euch einmal die Chance, die Zukunft eurer Spezies in die Hand zu nehmen, holt euch aus der Simulation und ihr wollt nur noch zurück in eure halbe kleine Welt.
Yeah, that's one character Vortex. And then we have the second one, Jameson. We did the same Reformer Pro thing to him. Just used a different library. So if we go here, we're all leopard again. This is Electronic Pro because he's a robot. Of course, he's a robot. So some little robot noises, which are filtered at this point because we are focusing on the telephone part. But the main sound of Jameson comes out of a vocoder. Now, what does a vocoder exactly do? It allows you to apply the frequency characteristics of one signal to another. We also call those carrier and modulator again, because the carrier is the sound that actually gets played, and the modulator is used to modulate that. And what we're doing with Razer here is that we're using the synthesis engine of Razer as a carrier, and then we're using our vocals to control that synthesizer. So if we play Jameson here, he's not saying anything because we're not giving him the MIDI input that opens the VCA of our synthesizer. And if we open this, it's just one long MIDI note because he's a robot, maybe not a very developed robot, which has like a very intricate speech synthesis system. It's just staying on one pitch the entire time, which allows us to play it like that. If we mute this, we can also just play this like a synth. Of course, it's the voice which eventually controls what sound passes our VCA and filter and such. Yeah, it's the filter in this case. If you look at Razer, we have actually the vocoder in a position where we usually would find our filter. And the rest is just the typical synthesis. Let's try something very deep. Not very understandable. Okay, that's a big robot and something high. Very little robot. Yeah, that's all that is to this main layer. Then we have a second one. This is just using some pitch correction artifacts to add those to the sound.
Sehr originell, das habe ich zuletzt in den 80ern funktioniert. Interessante Vernehmungsstrategie, muss ich schon sagen. Einfach dem Gegenüber Dinger.
Because our voice actor is not really singing, but the pitch corrector is trying to interpret what they are doing as singing, we get those funny artifacts when it just recognizes a pitch somewhere in the speech and tries to correct it to the next semitone, I guess, but then loses track again and is somewhere completely else.
Dinger an den Kopf werfen und hoppen.
That's very very funny way to deal with robots. I bet they did GLaDOS from Portal that way.
Strategie, muss ich schon sagen. Einfach dem Gegenüber Dinger an den Kopf werfen und hoffen, dass es so aggressiv wird.
Yeah, and then I filtered out the main part of the voice so I could stack it up with the vocoder.
Dass es irgendwelche Informationen herausrückt. Sehr originell.
Oh yeah, of course I have to turn the MIDI backup.
Schon sagen. Einfach dem Gegenüber Dinge an den Kopf werfen und hoffen, dass es so aggressiv wird, dass es irgendwelche Informationen herausrückt. Sehr originell, das habe ich zuletzt in den 80ern funktioniert.
Yeah, and then for some more, for a more realistic approach, I added the sound of a chair, which I also recorded at home, of course. Here, just a little bit, so that Jameson is, mostly sitting still, just moving around a little bit, and then a little bit louder when he actually starts to talk, just to add something to his character. Yeah, mixing wise, there's a lot of reverb on this. Which one is it? Yeah, Valhalla. Pretty long room. And another one a little bit closer with 0.31 seconds. Just also cut there. And then I just panned my Jameson components a little bit to the right and left Vortex in the center, just to give them both a little bit of a position. Yeah, and that's the entire play. Let's give it a listen again.
Ihr kummerlichen kleinen Maschinen. Immer wolltet ihr Unterdrückten sein, die Kämpfer, die Rebellen. Und dann gibt man euch einmal die Chance, die Zukunft eurer Spezies in die Hand zu nehmen. Holt euch aus der Simulation und ihr wollt nur noch zurück in eure heile kleine Welt. Ich verachte euch so sehr.
Interessante Verteidigungsstrategie, muss ich schon sagen. Einfach dem Gegenüber Dinge an den Kopf werfen und hoffen, dass es so aggressiv wird, dass es irgendwelche Informationen herausrückt. Sehr originell, das habe ich zuletzt in den 80ern funktioniert.
Ja, bitte. Aha. Okay. Gut.
Eine nicht 21,8.
Und da fängt unser kleines Missverständnis schon an. Das hier wollen wir alle vernehmen. Das waren sie nicht.
Yeah, I totally forgot about the telephone voice, but I guess you can by now tell which plugin I used. This is Reformer Pro again, using the Black Leopard library again, because, well, maybe the person who Vortex is actually called by is the same species as him, but I wanted something a little bit more gross. I'd say gross. That's why I added this fruit squash library, which is just some Foley handling noises done with fruit. With fruit, sorry, not with food. Well, yes, technically fruit are probably food, but yeah, that's that. Yeah, that's it for our little radio play. Moving on. Now we're switching the Cubase project. If it would let us. Is it crashed? Crashed while actually no project is running. Now that's just great. Doom, 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 doom. Is this still responding? Yes, it is. Task Manager to the rescue. Now here's just some professional Cubase pro tips. Kill it with Task Manager if it doesn't work. Easy as that. And there we go. And now we wanted to take a look at two new plugins, which one of which is new and the other one I just got recently. And this one just came out recently and I always wanted to toy with it, but I never got to. So this is like, I don't know, a month old or something like that. And it's called Pandulate. And why is it called Pandulate? Because it is based on the concept of a double pendulum. I actually had to look that up because I don't know what a double pendulum is. Is it two pendulums doing something in parallel? No, it isn't. Actually, or as far as I understood, it's one pendulum, and then there's a pendulum which is beneath that, which makes it a double pendulum. And then you have this pendulum moving around, and this moves it as well. Something like that. I hope I didn't. Whatever. And that's what this does. So this is plain how you boot that up, and let's just. I see. So we have the engine, which is this double pendulum, which I guess is a physics simulation running inside of the plugin. Then we have a wave folder. What a wave folder does, it at a certain point in the frequency spectrum, it folds the frequency spectrum back, and that generates the spectrum that we're hearing, I guess. If we turn that off to just listen to the double pendulum, we also have a low pass gate, a component that you don't find that much in synthesizers this day, because it combines the characteristics of a low pass with a gate. That's something that I think Buchla did in the beginning of synthesizers, but it hasn't, as far as I know, found much use since then. Yeah, let's just open that up. Or maybe we want a initialized preset as well. No OpenGL, yes OpenGL. I can do that. Okay, now that sounds like a sign to me. Show me my spectrum, please. Oscilloscope, not oscillator. Doop. Yeah, that's pretty much a sign, yes. Now, okay, let's try those parameters. Okay, let's go with those. I think I do what they do first. Sub oscillator, which is probably another sign. Oh, can do some interesting stuff here as well. Sub oscillator 2. 1 octave lower. Great for making basses. Thank you. Animate is probably a parameter which moves the double pendulum, which is actually not doing anything right now, because I guess I have to increase the amount. Okay. It's just swirling around. And if we turn it all the way up, we have a sign 1 octave higher. So right now it sounds like two sine waves that are just animated by... And this just adds to the complexity. But those sub-oscillators, they don't change, I guess. They sound pretty much the same to me, so it's just the main oscillator changing. So you get this version of the plugin you get for free, and I think they have a poly and beefed up version of that. Oh, that's great. So that's how fast our double pendulum swings. Oh, but the graphics are just great on this. I wouldn't really know what kind of sounds I'd make with this, but very interesting. Okay, let's try our wave folder. Oh, there's been a cutoff the entire time. Does this mean we're not dealing with a sine? Yes, we are dealing. Yes. All the way up. But from what I hear and see, it's at this point still pretty periodic. You can hear reoccurring things in the sound with every circle, which is probably the swinging pendulum. But of course, beauty lies in the modulation. I guess we have our modulators down here. Do we have an LFO? Yes, and it also has different outputs. That's the analog style to do it, because most Eurorack LFOs don't let you choose between different LFO shapes with a knob or something. They just give you an output for every waveform they can offer. Well, some of them do. So if we add this LFO to the chaos amount. We can change the intensity here or here. Now we can use a second one, for example, for this chaos shape. Yeah. That's the same output of the same LFO, so then maybe we should use the envelope. Is it also the VCA? No. Is this a... Yeah, this looks like it. Oh yeah, it probably controls the low pass gate if it's there in the graphical user interface. But let's use this for modulation, and we want it in ADSR mode. And you go there through animate. So, it can go negative as well. Very, very interesting, but it sounds pretty well straightforward to me still. That's interesting. This doesn't seem to do anything at the moment. Can we use key track for the LFO speed. Let's have it at a frequency. Because we could, of course, use this to make some interesting respaces or something. Okay, I really don't know what this is doing. Let's try some presets. Oh, that's pretty deep. How is it that wide? Did I oversee an effects section or something? Oh my god, it's so bright. So the little filter bump in the attack phase that adds this decay is coming from the filter. Big surprise. No, this seems to be already but how is it so stereo? Oh, nice little bass. Info. It opens up a web page. Okay, for me. Show me. Bottom half contains the modulation page, the effect page buttons. Okay. Where? Ah, that's the same thing. God, I'm gonna click that once more, I think. But I really don't see where this is. No, these are just my modulators. So if anyone sees where I can set my effects or something, please tell me. Ooh, that's a nice one. Okay, that's some basses for us. Let's try some leads. Is it more obvious with the other skins? No, I don't think so. Okay, I guess there's an effects section anywhere. Somewhere in there. Okay, show me something completely different. Oh. Here the LFO is modulating the chaos shape. Yeah, I see it's a tall white bass and it does sound like that, but how do you... Some presets. Okay, let's sum this up. Very interesting concept. I liked that the the main thing in this plugin, this double pendulum, which is like your oscillator, is a moving object unless you stop it from doing that. When it becomes just a mixture of two sine waves, interesting concept, I'd say. Yes. Maybe be able to manipulate that a little bit more. I've seen a physics simulation of a double pendulum in preparation for this for dealing with this plugin, and then it had several parameters that you could change that were, well, they did something a little different compared to this. Sounds very interesting. I'll probably just check out the full version of it and see if it gives me an ability to play with the effect section or something. Okay, second plugin that I wanna try out came out in January, as far as I know. It's also by Krotos, who did those post-production sound design plugins. And this looks more like a synthesizer that I can actually control. So, night mode, dark mode. No, night mode, day mode. Yeah, let's keep the dark one, it's pretty fun. This looks like an oscillator, which lets me blend between two waveforms. Yes, I'm not mistaken. This is our sine wave. This is a saw, truth. Ah, we can also change those. Yeah, Chris, very clever. Let's have the two square waves and not let the blend thingy do anything. We can detune the oscillators. Okay. Now that's pretty straightforward. Gain just makes it louder, does it? Yeah. You can see on the oscilloscope that it doesn't change. Ooh, FM right in the oscillator. Very nice. Oh, the depth scales exponentially, I think. At least the number on the knob does. Very nice. Second oscillator. Yeah. Then what do we have here? Filter. With drive right in the filter. Very nice, very nice. Let's go to a lower octave. Thank you. different kinds of filters. So as I told you, this is a low pass filter, which lets the low frequencies pass and cuts out the highs. You can also have this looks like a high pass filter. It was a high pass filter, which keeps the high frequencies and cuts the low ones. This is a band pass, which cuts in the middle and just cuts out things left and right in the higher and lower frequencies. So it's like a combination of a low pass and a high pass. Ah, it's a Forman filter. Show me the Forman filter. Forman filters are, I think internally they are made of like 3 band passes, which model how sound passes through our mouth. So we can actually form language with our mouth. Yeah. Yeah. So if you want to make some ya-ya basses, then this is your tool. Let's take this LFO and modulate. How do I modulate? Drag and drop here. Do I drag and drop to there or from there? Okay. Maybe in the... Maybe I can right click. That's gonna work. Oh no, I picked the blue one. Alright, what else do we have? Some effects. Those are... Oh yes, a mighty saturator. Oh, that's some good sounding saturation. Also a reverb. That's probably the same as in the other Krotos plugins. Not bad. But I already saw someone toying with this, and I think that the interesting thing are the modulators, which are a little bit different than what you'd expect, because you have LFOs and envelopes, all good, but you can also have audio input routed into the plugin and use that as input, as modulator for your sound. That's something very interesting, and you can also do this XY capture field, which you can actually capture some modulation with, and then it remembers the motion you made, and for example speed it down, and then you have the x-axis and can modulate something with the x-axis and the y-axis to modulate something different. So if we remove the LFO here, clear modulation, and add the x-axis to the cutoff and the y-axis to the... Oh no, let's maybe clear that and to do that to the vowel. If we change it to perform now. Okay, let's record one more. Okay, normal speed. That's great. Okay, let's make some music. It was my plan to make some music at the end of this workshop, so let's use this crazy sound for it. That's a little bit lower. Okay, let's do something dancey. 128 BPM. Yes. And we're gonna slice that and quantize that, because that is what we do, slice and quantize. I usually sing while I'm making music, and my singing doesn't have anything to do with what I do. Oh, is it set to mono? I want it in mono. And some nice glide. Give me some. Okay, we need some drums. Which synth are we going to use for drums? Go and tell me in the comments which synth we're going to use for drums, while I think of something to do with Pandulate. That's a pretty nice sound, actually. I just can't take any credit for creating it. No! Okay, let's turn this up. Let's just throw some notes in there and then we'll see what we do with it. Now, that's not the most interesting sound I ever made. Let's see. Use a TR-909. I sadly don't have one. Sorry. Not even an emulation. I could use samples, but that's kind of boring, I guess. Yeah, just widen that up. Maybe do some... It's never stopping. Okay, we need a kick drum by now. Kick drum, kick drum, kick drum, kick drum. kick drum. Let's just go old school. Just do analog, or more like wavetable, but analog. Let's make a simple kick drum on all the 4 quarter notes. Do you ever work in Logic? No, sorry, I don't. Which is mainly because I don't own a Mac, and when I work on someone else's Mac, then that's mostly either Cubase or Pro Tools sometimes. But sorry, no Logic in my workflow. It's all chaos. No, seriously, I just didn't get around to. My first machine was a Windows, and I pretty much settled for Cubase, and now I know all my shortcuts, and it would just take me hours to learn the same amount of shortcuts for Logic. So if one day there's a very compelling reason, there actually is one, because they bought Camel Audio a while ago, so some of my favorite plugins are now Logic exclusive, like Alchemy, or well, I bought an old version of Alchemy Player, and I can still use that. But I didn't purchase, for example, Camel Fat as a full version, and I really, really regret not having bought that a long time ago. And at some point it just won't be supported anymore. The version that I have, I mean. Okay, that's our kick drum. A bit simple for a kick drum. Now we want to filter the very clicky bit out by using the DCA envelope. Not my greatest kick drum, but it will have to do. Now what I usually like to shape that sound a little bit more is do a transient shaper. That's pretty fine. Do some EQing, because I want more weight and less Then I just clip it. Standard clip. Software Pro. Just to add some saturation to it. I still want it a little bit shorter. Oh, that's great actually. Maybe move it down a couple of semitones. Yeah, that's gonna do. I really like the sound, but it has to like move out of the middle. So let's add a chorus maybe. That's pretty okay. How is it called? No, pitch. No, I want the Sound Toys one. How was it called? Wait, don't I have? Yes, I have those separately. Shift, yeah, micro shift, sorry. And that has this acoustic guitar white preset. Which is doing it white without the chorusing. And now I want to bring my bassy bit back to the center of my stereo field. So I use the free HOFA tilt EQ, but I don't use the tilt function. I just use this high pass filter to filter out the side information. This needs more bass. Yes, sidechain, that's a good idea. Let's do some sidechaining. What kind of sidechain do we do? First of all, name this kick. Do we do real sidechain or do we fake sidechain? I think we're gonna go for fake sidechain because it's 4/4 and no compound meter that requires some advanced shaping. So we add those to a group channel and call that master sidechainer. It's called master sidechainer because it's like feeding right into the master, and I mostly add everything that is not drums into that group. Is it sent to my... Yes, it is. That's some great sidechain. What this does, this is a shaper box by Cable Guys, and it, as the name suggests, allows you to shape your audio, and it does so by allowing you to draw this curve, which you can draw however you want, and then it just repeats that periodically. And if I set it to 1 bar, it's of course a little bit pointless because it's only gonna duck for like the first of the 4 kicks we have in each measure. So let's set this to quarter notes. That's gonna do for now. Okay, this sound needs to be a little bit tamed. It's awesome, but it needs to be tamed. Can I have another filter? Yes, I can have another filter. Yeah, just to create some space. Shall we do more drums? I think more drums. Let's make a hi-hat ourselves. I'm gonna use this trick, which is using FM8, but not using it as a FM synthesizer, but using it as a additive synthesizer again. And we're just gonna offset some square waves, which is roughly how the I think TR-808 hats are made. No, we blast those through the filter, which is this one. Yes, exactly. So the routing matrix lets us choose where we want to send our waves, which we of course also need to send to the output. So far, it's a those are sine waves, like if we were to do FM synthesis, but we need those harmonics, which is why we go square on all of these. Ooh. There we go. Then we just filter out some of the low end with this filter, which we can set to a high pass, right? That's not a high pass, is it? Now that's one nice sounding hi-hat. Yeah, that's more like it. And is this our filter envelope? Oh, I think we need to change all of those. Now that's going to be a little bit time consuming, but that's okay. Because we don't have a master envelope or one carrier that is going to the output in the end, so we need to give those a decaying form. Yeah, that's a solid foundation for a hi-hat. Saturation, HOFA saturator, saturate my things. Yeah, second one didn't go as planned. Yep. Yep. This one's too short. We want the full envelope on all of those. You can hear when I shorten one of the envelopes that something is like sticking out at the end of the sound. Okay, let's maybe put some... Oh, we're actually not going to use this hi-hat at all. Look what just came to my mind. If we don't use this hi-hat at all, and we instead use... Ha! I had just spoken about it, but I didn't think I'd actually use it. We can send audio into this plugin. So let's call this one a ghost hat, and then we send it into a completely other synth. No, that's gonna be great. That needs to be pre-fader. Is it pre-fader? Then on this one we just put one long note. change this to audio input. Yeah, there we are. And that's all. Then we can use that, for example, to open the filter. This is gonna be great. Okay. Let's put this here. And now by changing the dynamics of this signal, for example, by removing that saturator, yeah, that's like it. Okay, now we gotta clear the noise. That's great. It can also detect the pitch. Oh, that's interesting. Oh, maybe another time. Oh, this is sweet. Oh, is this operating in stereo? Not really what I want. Maybe that's what I want so far. It's a little bit late for my feeling, so I'm gonna use a track delay to... Oh, that's the wrong plugin. Let's put this first and move it. Okay, maybe a simple shaker on the offs. Just gonna use that one trick that I learned from a preset, which is again using these functions to make a shaker function. You go to this. Then we can just create a simple shaker loop by making this one bar. Yes, there we are. Thank you. want this to actually be a pitched sound, I guess. Something more like a drum, so let's give it a tonal component. We need that audio input again. I really like what this is doing, but it's a little bit too complex for the tune. But that can yield some very interesting results. This is Isotope Trash 2, which is a multiband distortion unit, which allows you to not only apply different levels or grades of distortion to different bands of the audio spectrum, but also completely different algorithms. And it comes with also a player for convolution samples, which allows you to, for example, bring in a guitar cabinet or something like that. It has a delay, it has dynamics. Very interesting tool to completely trash something, but also, well, it's not exactly always predictable what it's gonna do, but it's, well, very, very, if you understand how it works, it's pretty easy to change what it does. Yeah, something like that. That's a nice sound. I want that. So in this case, the actual trash algorithm is taking some of the high out, and the sound actually comes from from the convolution module, which implies a impulse response of a whisper. A whisper. Of course, feed a shaker into a whisper and you get this. Okay, but I really want that doubled with some drums. Let's do chromophone. Do. Where is my step? No, it's not my step, it's my hat. Yeah, we can start with that. More attack. Then I guess we can just EQ what we want into it. Gated reverb. Crush them. Oh, we could do with some bit crushing. What's that one called by native? Byte. Yes. Yeah, that's what I was after. Those nice artifacts where the downsampling is happening. And then post EQ. Transient shaping. That's not really working. That's always taking the first tom and then it just ducks. What we can probably do is use shaper box and MIDI trigger it. So if we do like a square, yes, then we send our MIDI from the ghost. Oh, we can actually send the toms themselves in there. No, we can't. How does that work? Wasn't there MIDI sense in Cubase? Anyways, it will work if we use a separate track. Tom trigger. Let's call it Tom trigger. Hello Tom, how are you doing? Are you triggering any things lately? Tom's shaper box. And then we gotta set this up to MIDI. And solo the track. Oh yeah, I have to copy the MIDI events over. Yeah, that's working. Great. Resolution, let's do 8 notes. A little bit more. Yeah, that's doing pretty fine. Okay, maybe do the toms only every second time? Or just leave a gap there? That's weird. This needs a drum group. Perfect. That's doing too much. I also need some more attack in the kick. Yeah, that pretty much concludes our stream for today. I hope you all had some fun and probably learned something about synthesis or effects or sound design in general, sound design in post-production, sound design in music. Of course, there's only so little you can do in 3 hours, but I hope to have at least entertained you a little bit. For the German-speaking ones, Sie spreche Deutsch, we just launched the sound design course where you can learn all the in-depth things about sound design that didn't make it into this workshop and many more. And for the English people, sorry, you'll have to wait for a while until this course becomes available in English, but it's gonna happen. So everybody, stay safe, stay healthy, watch out for yourself, and until next time here at HOFA-College, my name's Chris, and I'll see you next time. Goodbye.